Let's talk about finding domains of functions. We're going to do this two different ways. One way from an actual formula function and also visually from the graph. So let's talk about the formula version first. If I'm looking for the domain of a function, there's really at this point only two things that I'm really concerned about. The first is when I have fractions, I cannot let the denominator equal to 0. So I have to exclude any x that would cause my denominator value to end up being a 0. And the reason for that is that a fraction is just another way of writing a division problem, and I cannot divide by 0. That's undefined. The second situation we're going to have to be concerned about are square roots. And the reason for that is when I take the square root of a negative, I get an imaginary number, not a real number. So we're going to want to keep that expression that's under the root non-negative or greater than or equal to 0. All right, so let's first take a look at an example where we have a fraction. I really don't care what this top value is. I can put any x in there. I can get any number. It can be 0, a half, a fraction, a decimal, an ugly number. It doesn't matter. What I care about is the denominator. Okay, I cannot use an x that would cause this entire expression to be equal to 0. So in order to find that, I'm going to take that denominator, x squared plus 2x minus 3, and set it equal to 0. And because this is a quadratic, meaning I have an x squared and not just an x term, I have to solve by factoring. So we're going to break this down, kind of unfoil, might be how you've learned it. And x times x gives me my x squared. Positive 3 times negative 1 gives us our negative 3. And then I double check. Negative 1x plus 3x combined to give me a positive 2x in the middle. So it is factored correctly. If I have something times something equal to 0, then that means either that first something is 0 or the second something is 0. Solving both of those, we get x equals negative 3 or 1 will cause the denominator to be 0. That's what we don't want, so we're going to exclude that. We would say that by saying the domain is all reals except the negative 3 or 1, or this is what we call set builder notation. It's the set of all x, this vertical line is read such that x is not equal to negative 3, x is not equal to 1. Another way I could write this is an interval notation. So I would go anywhere from negative infinity, I can draw this in here, to negative 3, and then we're going to skip that, so parenthesis, then I would go from the negative 3, again, skipping it, so parenthesis. I'm really bad at writing like this, and up to the 1. Then we're going to stop right before we get to 1, exclude that, and then finally we get one more section, and that would be from 1 all the way to positive infinity. So we had two exclusions, and I actually put two holes in our number line, giving me 3 separate intervals. Let's take a look at another one. This one is a square root function. We've looked at this graph before. Okay, so it's graph for us here. We can kind of see visually on the graph, but I could also take this and solve it algebraically. What we would do is we would say x plus 4, that's the part underneath here, has to stay not negative. In other words, has to stay greater than or equal to 0. That's pretty easy to solve, right? We would just say then x has to be greater than or equal to negative 4, right? And that would be negative 4 bracket, because I want to include it, it's got the or equals, to infinity. You can see that on the graph, because where does this black graph start? It starts way back here at negative 4 and goes forward. It doesn't go anywhere behind that. So what we did algebraically matches up with the picture. And what about the range? That one, we're just going to look at the graph. We don't see any part of this half parabola below the x-axis. So we're going to start our range here. It's noted in blue, and it's going to go upward. You always give your intervals from lowest number to highest number, so from 0 to positive infinity. Again, we're going to include that endpoint because this point back here, negative 4, 0, is on my graph. All right, let's look at a couple more. So looking at the graphs, I've got my domains noted kind of in green and my ranges in red. And sometimes it's the parentheses and the brackets that confuse people. So in both endpoints on this first graph, they're open circles. Okay, so that means those endpoints are not included. So when it comes to my domain, I'm going to figure out where does the graph start. Okay, way back here. On the x-axis, that corresponds to -1. Where does the graph end? Here, right at the 4. So on the x-axis, I'm going from the -1 to the 4. Neither endpoint is included because it ends at open circles. Now on the range, that's the y-axis. So the lowest spot of the graph is down here. Come over, that would mean I'm starting at -4. The highest spot is up here at 5. And so I'm going from -4 to 5. But notice when I wrote my range, I put a bracket here with the -4. The reason is because this point is actually on the graph. It actually does attain a y value of -4. Up here, this is an open circle, meaning it gets really close, but not quite to 5. The second picture here, we have a filled in circle, so that means those values are included, and an open circle over here. So again, the way you determine the domain, you take your graph, where does it start? Note that on the x-axis. Where does it end? Note that on the x-axis. So from -2 to 4. -2 is with the solid dot, so it's included. 4 is with an open dot, it's not included, parenthesis. For the range, how low does it go? Its lowest spot is down here at -2. Highest spot is up here at 5. The -2 is the open, so it's not included, parentheses. The 5 is with the filled in, so it's got a bracket. All right, last two real quickly. We've got parabolas. So the arrows make a difference. It's indicating that it's going outward in both directions forever and ever, as well as going upwards. So the domain on this is going to be -infinity to infinity. That's the same whether the parabola opens upward or downward. Now what about the range? Okay, so the range is the lowest spot to the highest spot. This parabola starts right back here at -1, 1. So the lowest y value is a 1, and then it goes on forever. So we're going to start it at 1 with a bracket to infinity. This is where you have to be careful with order for intervals because it's always lowest number to highest number. How low does this parabola go? To -infinity. How high does it go? It stops right up here at -3. So notice the order I wrote that. -infinity comes first, then -3 with the bracket because that's where we stop, right up there.